there. I need like you keep telling us. That sounds like fun. Awesome. All right. Mine was pretty standard. I took the dogs somewhere for hiking because the weather chilled down a little bit here in Austin, Texas. And it was fun. Did a lot of cleaning. Tried to catch up with some extra curricular stuff that I've been doing. A little bit of work. Yeah, not as fun as camping, but it was okay.
Camping is really fun. Yeah, Edgar is here right me. beside
Hi, good.
It was fun. Yeah, like we went out for the first time like in 7 months or so. So like yeah, we wanted to buy a stand mixer for a long time. So and we're like cooking a lot right now. So we wanted one and we went to like to a mall to buy it. It was really weird because like we weren't like doing any plan like that one like in 7 months. But we were really happy about the mixer. So yeah.
What is it? I was muted. Is that one? Hmm.
Let's get going. Let's kick it off. All right, great.
All right. Well, welcome everyone for another installment of Quansight's Quirkshops. As you guys know, the Quirkshops are designed to have be a conversation around technology and how that technology impacts our lives, our businesses, and our societies. We bring together people that work with technology. That includes those people that are creating algorithms and those individuals that are creating the tools so that those algorithms can be used by other people, as well as practitioners of those tools. So today we are actually going to be talking about deep learning. And deep learning is a very large subject in and of itself, and it's used in many different areas, including natural language processing and image analysis. So we are going to limit the scope of the subject and just have a gentle introduction to deep learning and have our experts talk about a little bit of the introductory material to deep learning. And with that, I would actually like to introduce our experts, Fatma and Stephanie. Fatma, how are you doing today?
Okay, Andy.
Good. So why don't you tell a little bit about yourself to us?
Sure. Thank you, and thank you everyone who's watching right now. I'm a data science fellow at Consight, and right now I'm working with open teams trying to make sense of data. And I am located in Austin, Texas.
Great. So what exactly are you working on these days?
We are doing some data project for open teams, trying to get collect data about open source software and how we can make sense of it and channel some of the resources and efforts to the right places and get more support for open source. And I am also working on prototyping a little conversational AI right now. Hopefully, it will become a good prototype that I can demo later on. And yeah, that's what I'm doing right now.
Great. So actually having some deep learning and AI being useful for the open source community. That's great to hear.
Hopefully, it will. Yes.
Yeah. Stephanie, so tell us a little bit about yourself.
So I'm working here on Quanside as a software developer. I have been doing like a mix of works. So right now I'm part of the Spider team. I'm also helping in a client's project, and I'm also helping in the PyData consortium. So it's really fun, like I am able to move to do a lot of things. So in the past I've also like helped for some clients work using machine learning and deep learning stuff, which is also nice. So yeah. Oh, and I'm located in Bogota, Colombia. So yeah.
Great. So I know a little bit about Spider, but for those that aren't familiar with it, do you mind giving a quick introduction about what Spider is?
Sure. Well, Spider is an ID, like an open source project. It is completely free, and we maintain it to, make it better. Our focus is mainly on people who are working on the scientific part with Python. So basically, we try to like develop a really good tool for them to be able to develop things that are going to go to the scientific community. So it is really nice. We have a lot of like people and users that are really like engaging with us all the time in our GitHub account. So yeah, it is really a great project.
Great. So it's a good example of open source technology. And I'm assuming that you are building your machine learning tools and algorithms in Spider.
What's funny is that we don't use like any machine learning or deep learning model or algorithm there. So basically in there I'm just working on software development, like plain stuff, like things of the architecture, like fixing bugs and like developing new paints and things that are not that complex, like behind scenes. But I think we like in the future we can like start thinking about something that will integrate a little bit of this topic to the ID.
Great. So still making the tools that,
Yeah.
right. Yeah. So wonderful. So I'd like to ask now about the experiences you guys have with using machine learning, deep learning, or data science in general. So Fatma, how long have you been a data scientist?
I have been a data scientist for over a year now since I joined Quanside. And prior to that, I was mostly in academia and research domain. And I guess my involvement with deep learning and machine learning started about 4 years ago when I sat in a class in my graduate program on NLP. And since then, most of it was my self-learning and following the development and research in the field because I was like really fascinated and I'm primarily interested in NLP for those of you who don't know that yet. But yeah, since then, since Coincide, my work primarily was on data science and I also had some opportunities to work on projects that required machine learning, both for a client and some training. So yeah.
Great. And so NLP is natural language processing?
Yes, sorry, I should have clarified that. That's natural language processing.
Great. So are you teaching a computer to speak?
Trying to more so. Yes, part of it is like speech, but the other part of it is understanding the language, the natural language, so that it can perform and make sense of spoken or written language.
I'm sure that's quite interesting, especially having to deal with the language that's being used on the internet, because as we know, Twitter speak is not really a conversational speak that you would have with
Yes. Yes, in the earlier days of NLP, most of it was like very structured and grammatically correct natural language. But once it started to expand its range, I would say, and the applications to social networking and social media analysis, there has been some research and models developed on like understanding slang and like little acronyms and things like that, emotion detection, emoji detections. So they're all like being developed and being actively researched right now, which is great. Very interesting.
Yeah, well, as someone that does not understand emojis whatsoever, hopefully I can use one of your algorithms to teach me what those silly faces actually mean.
I actually mean, yes.
So, Stephanie, how long have you been a data scientist?
So, like, I primarily started working with, like in computer vision, like maybe 4 years ago when I was in my undergrad class that was of biomedical image processing. So that's where this whole thing started. The main focus for my computer vision tasks are in research. Like I've never used those models in a real life application or for a client or anything like that. Mostly everything was research. Then when I started here at Quantside, as I had that experience, they started to call me to help them work in some of the clients' project that require some research, like not research, but more like data scientist type of thing. So yeah, like that's like my majority of experiences on the research area and the academia. So yeah.
Well, I would personally offer saying that research is real life, and it does impact society in general. It may not impact us in society directly in like 15 minutes, but it certainly does impact us. So I would say that it is quite real. So that's great. Primarily, Stephanie, you've been doing machine learning with image analysis, and Fatma, you've been doing machine learning with natural language processing. How about deep learning, and how does that affect both of the subjects? Stephanie?
So basically, like the majority of the models nowadays that are used for like image, like processing image, they are all using deep learning things. So deep learning is like a really big like concept for the computer vision tasks, because like really nowadays the machine learning like non deep learning models are not that used because they don't have the same like um how do I say this, like accuracy, and they don't perform as well as the machine learning ones. So yeah, basically deep learning is a huge thing for computer vision.
I think same thing applies to natural language processing as well, because through deep learning, we are able to use neural networks, which are like these computing systems that are modeled after human brain. So in a big neural network, in natural language processing, the machine is able to understand more and more the natural language that it reads or hears. So like same for computer vision, like Stephanie mentioned, it's it seems like both the research and industry is moving slightly away from the strictly rule-based, so-called old, not old, but traditional machine learning realm to more like deep learning domain to get better accuracy and better performance and better results, and also applicability.
Great. Now, you mentioned the word neural network. So, what is a neural network, and why is that different than a regular machine learning or your
Yeah,
run-of-the-mill machine learning algorithm?
right. Am I unmuted? Okay. So a neural network is basically a collection of connected units, and they're called artificial neurons. And these neurons are organized in layers, and the reason that it's called deep is because we have multiple of those layers, and it's a very deep network. What happens is that in each layer, the system takes the artificial system takes an input, does some transformations, mostly some mathematical operations, getting the probability of a certain output, and then passes it to the next layer. And of course, they're in different neural network or deep learning models and architectures. There are different ways of doing it, like going back and relearning, or like correcting a mistake that a layer has made before. Or more recently, now we have transformers that are using attention mechanisms, which are like a little bit of a complicated architectural system in deep learning that I don't think we have time to get into. But attention systems can have like a long span of attention, can move back and forth in the layers in a network, and compose a sort of learning until it spits out an output at the end of the network. So I don't know if you have anything to add, Stephannie, but please do so.
Yeah, I think the only thing I have to add to that is that with the neural networks, we're able to like model like non-linear distributions by having those layers of different units, because each unit has a linear transform normally. So what we do is like all the sum of that can create like a non-linear thing and move to a space that we don't understand, but the machine does. And in that space, we are able to, depending tasks, separate the things that we want, or, like detect things on those kind of tasks. But yeah, basically that's why they're so popular now.
So when you say linear, you mean like here's the y-axis and here's the x-axis, and it's a straight line?
Yeah.
So what makes a model that's able to predict a straight line versus something that's, I guess, wiggly, so not a straight line?
Like if you compare like a linear model, like a vector support machine with a linear perception, they are the same thing. Like you see like the mathematics that is like behind that, and it is like the same, they are doing the same thing. Like what's different about the neural units is that we are able to put not just like that straight line, but we also have other transformations that can be used to try to model the data better.
So this basically goes back to what Fatma said, where it is a new technique that does a better job of predicting and trying to understand a system. So previously we had tools that gave us good results with systems that were linear, but now we found problems that weren't linear, and we needed to develop tools that could try and figure out ways of predicting nonlinear situations. So that's great. And so my question now would be, what is it that is so great about the being able to predict nonlinear systems? Like, is it going into the realm of the dreaded word artificial intelligence? And is that artificial intelligence hyped, and is it real?
I'll let Stephannie take on that first.
Okay, so basically my definition for deep learning, because like I've seen that throughout the web and throughout people, that changes like like a lot. So really my definition of deep learning is we're just trying to adjust a model to a data distribution. So if we're able to have those non-linearities and in our model, we can fit the data better. So that's why people always say like, oh, for deep learning you need a lot of data, because if not, we're not able to fit the model into the data, which is something that I think a lot of people doesn't have clear. And yeah, like the hype is that, well, I don't know if everyone has seen like right now that everything has AI into it, and just by applying that word, like things get really expensive. So for example, I found a product that I laughed a lot because it was a washer machine that had AI. So I was like, what machine learning or what deep learning you can put into a washer machine, and I read the specifications, and they only had like a simple, like a really really simple architecture, like of 3 layers, that will like help you to determine which cycle of your clothes will be better. And yeah, I was like, okay, like that doesn't make any sense. And really, in the like in the video, in the promotion video, they had like they put an like meaning to each layer. So, oh, this layer will tell you the softness, the other will tell you like how rapidly to speed. And I was like, okay, like in deep learning models, we are not able to like know what each layer is doing, like being completely sure about it, because you're just putting a lot of layers of none of a lot of like activations and things that not you don't understand really what's happening there. So like for me, seeing those products like advertise that, oh, this layer will be for that thing and the other for the other thing, I really found it really funny. But yeah, I don't know, like people really like to use the word AI for everything nowadays.
Yeah, I agree. I think there's definitely a perceived value about a product or a service if the word AI or ML is used in it, and unfortunately, it's I guess taken advantage by a lot of business owners or product owners. But I also think that the hype is real. I think I agree. I agree with you both. It's there, and people are taking advantage of it. But I also appreciate the fact that, like, with deep learning, especially more recently, we have been able to do things that we were not able to do before, such as I can more informally speak to the NLP space, but you can now like read a huge corpus of textual data and get some great insights from it that you wouldn't be able to do in the past, or maybe not so efficiently in the past. And we see that applications of particularly for NLP and vision too are might be hurting and in some aspects of it to certain people or services, but it's also helping a lot of people and science in general, I think. So that's the part that I'm really excited and I see that as very very promising in some areas. But the use cases, like the example you have given, Stephanie, is definitely like, please, please don't. But yeah.
Yeah, and also something that I see that's happening is that a lot of people, that is building a company nowadays. Like a lot of my peers of the of my undergrad, they will call me and tell me like, "Oh, I have a job for you. I need you to, do this deep learning model because I want to, I don't know, like, I want to." No, that one makes sense. I'm thinking about one that didn't make sense. Like I want to. I don't remember. It was like I've been heard like a lot of absurd things, but that's also helped by the hype because people think that the this tool is able to do everything, and like really like they start to not like define problems like really bad. So when like if you're like, I don't know, if you're working for them, they will expect a lot from you, and then the data scientist will be the bad guy because he wasn't able to accomplish the goal that the business wanted. So I think that's also like something that we need to like be more aware of, because yeah, I think like there's no that disclaimer for business people, they think everything's capable because it has AI and because the machine can learn. So yeah.
So that's great. So that gives me the question of, is AI and deep learning and machine learning just the catch-all for everything? And can it actually give you an answer to everything?
Um, it might be used as a catch-all by a lot of parties, but I don't think it can give you the answer for everything, at least not yet. There are like, some utopian ideas about, we can actually achieve artificial general intelligence, which is like achieving the level of human intelligence by using machines, basically. There are a lot of people who believe in that. And I don't know, I'm a little bit conflicted. Maybe we will, but I don't know when. But I also think that it will increase. It already is affecting our lives, everybody's lives on a daily basis in like little, even the slightest things that we don't even realize. and it will just increase. We will just see that effect and influence in our lives increasingly more. So, but it's definitely not an answer for everything. And most of the time, if we start talking about the data and problems with it, this discussion will take like hours. But that is a huge part of where ML or AI can take us. It's only going to be as good as our data, basically.
Great. So it's not the solution to everything, and you can't make every decision based off of it. You have to have some sort of context and story behind what the deep learning model is actually attempting to do.
Absolutely. And also what kind of data it was trained on to acquire its knowledge.
Great. So what kind of tools, Stephannie, do you use that facilitate your building of deep learning models?
So basically, I started with using PyTorch. I remember that my first model was made on PyTorch 0.2, which was a long time ago. Yeah, like for this workshop, I wanted to like show some of those models, but I was really sad because I couldn't make them work. Like the weights that I have don't match, and they don't like it runs, but it doesn't like get the result that I obtained 3 years ago. So yeah, I was really bummed like that. I was really sad. But yeah, I mainly use PyTorch. I've touched a little bit of TensorFlow. I don't enjoy TensorFlow as much because I think it's more that like a black box for that. So I prefer to have full control of what I'm doing and how I'm creating the model. So I think that PyTorch does like a best job on that. So yeah.
That's interesting that you say that you weren't able to reproduce some of the models that you built in the past. And it goes directly into the conversation of these models are not all always going to be able to give you an answer and keep that answer for all time, basically. So is that because of the data that you use, or is it because of the algorithm?
I think it's more about that on the earlier versions of PyTorch, the weights will not, you cannot share weights that you trained on a certain version of PyTorch with another ones. So, like, if I found a model that had a really good accuracy and they ran it and train it with a certain version of PyTorch and a certain version of CUDA, then I will have to run it like them. If not, I will not get the right answer as them. So yeah, that's like really a bummer because like in my research experience, I think this 70% of my time was trying to like reproduce papers, and that's a really horrible task because it is so hard. And yeah, like sometimes I remember like I have one paper I couldn't even get close with their code and their like instructions to run. I wasn't able, not I didn't get the same results on STEM. So yeah.
That's interesting. We have a question from Tony. Tony, would you like to say something?
Yeah, absolutely. This is a question from Tony by way of Anthony. So he had a long question. It has an intro, a middle part, and an end part. Current and near-term processors seem energy efficient when at deep learning type problems. It seems like binary logic gates are really bad at representing neurological connections that happen in nature. In what directions are the AI ML space moving to address the energy consumption issues? Well, this wasn't about ethics, but it could be.
So, if I understand correctly, this question is about mostly the amount of energy that is used to train big models. Is that so, Tony? Did I understand correctly?
Yeah, it seems like that. Like how much snow is going to melt when models are trained in glaciers.
Right. Yeah. This has been an active discussion lately in the field, and a lot of people are concerned about its environmental effects to train these like billions of parameters models that has been going on lately, especially the language models. And it definitely has a carbon print when it uses some server somewhere around the world, and it creates a lot of work. What to counter this problem, I know that there is some active research going on about to acquire, like to get the same type of results by actually using tiny data, it like small amount of data, and so that it doesn't, a big model doesn't have to train for months to be able to produce the same results, same accuracy or performance. I don't know how far it has gone yet, because it's like quite new, like maybe last year or a couple years, and there's not a lot of improvements just yet as far as I know. But it is an issue. But on the other hand, once a big model like GPT-3 or the ones that ML from Microsoft, I think, those are really big models that took probably a couple months nonstop training on a very high performance GPU somewhere in the world. But once it is trained, and if they open source it, you can actually just use the model so that and take advantage of its learning without having to train it again, and you can apply it to your small amount of data and train maybe just a couple of hours and use its knowledge on a different problem. That's one way of dealing with it. But going forward, I feel like there will be like some method or technique that will be able to achieve not having to train on so many parameters or so long. I'm hopeful, but we will see, I guess. It's in this field especially, it's so fast paced, like things change like in a month. Like when I last year I was I participated in a research program in a research lab for a while, and back then GPT-3 2 was the biggest language model, and like, oh, it's great and it's doing a lot of stuff, and everyone was so excited about it. And 2 months later, like Microsoft came up with one, Google came up with another one, and right now we have GPT-3, bigger and bigger models. So it's changing so fast. So I'm hoping that they will be able to figure out that some way of not having to use that much energy to produce them. But then to just put it into perspective, this was actually provided in a paper, I think, by Google researchers. One of the biggest models, I think it was, maybe it was BERT, maybe it wasn't Google, but that the amount of energy produced, the carbon print, the produced training that BERT language model was equivalent to a flight, a round trip from, I believe, New York to San Francisco. It's just like, think about one flight and the amount of carbon that a flight produces. And it was more or less equivalent to the amount of carbon print that this model produced. So if you put it into perspective, it's bad, but it's not like the worst thing in the world.
So when you make a model, you can reuse it over and over again with different data.
Yes, if these models are the weights, meaning the learnings, the knowledge from that model is shared by the producers or the authors, you can use it with a process called fine tuning, which means you kind of appropriate that learning and weights into your own problem, whatever task or whatever problem you're trying to solve, because the model originally is probably trained for a different problem or to achieve a different task. But you can take those pre-trained models' weights and fine-tune it and apply it to your own data and your own problem. The limitations are the pre-trained model knows one thing and it will never change its mind. But you can still make use of it if you think the results are accurate or useful to you. Yeah.
Great. So the weights that Stephanie was talking about are actually what the machine is saying, the learning. So when you learn something, you obtain weights. That makes sense.
Yes.
Yeah. Yeah, but I think that also it's important to mention that for training these big models, like for example the ones that Google or Facebook or Microsoft are producing, you need so much power that like even like I think we are not able to, you know, like to retrain it from scratch. Like if I try to run those models and try to like make them like learn for myself, I will need like at least 8 GPUs, like 8 really good GPUs that cost a lot of money. So yeah, like right now, I think the research, like even in the research area, they're just going to grab the one that's performing its best, and then they will try to apply that and fine tune it for another problem. Like that also happens in computer vision, which is kind of a bummer because, like, you know, like when I started in research, I really wanted to do like something from scratch for myself. But when I found that really like the industry is moving towards that, it's like you have to trust that those weights aren't like they didn't cheat, they do the thing that they say and they report in the paper, because you will not never be able to even try to, you know, get to the same result from scratch. So yeah, I think that's also something worth to mention.
So you're saying that you can't really retrain a model to change its mind, but you can nudge it into a specific direction by fine tuning the weights.
Yeah,
Yeah.
that's that's what we do basically. Yeah.
So you can teach a model the difference between a dog and a cat, but you can't use that model to say that a cat is not an alpaca.
I think yeah, but like we can create something to use those weights that are already pre-trained that makes sense into our problem, and train with and make sense with the data we have to train it to output something that we will use and that will give us value. So
Yeah, yeah, that's I agree with that. And but you can, to back to your question, and you can make that model to say it is not a cat or not a dog. It wouldn't say it is not an alpaca, but it can tell, it can negate it and say these two are not the things that I know. So it is something.
So you can actually make a lot of different models that say, no, it's not what I already know, and then choose a different model to say, yes or no, it's not what I already know, and then make a decision of something being a cat or a dog or an alpaca.
yeah, if your data just have dog, cat, and alpaca, then you will be able to do that.
Great. So so let's talk a little bit about the use cases. I know, Fatma, you had described a little bit about natural language processing and attempting to understand literature. So what is some relevant problems that you can think of right now that would be useful for understanding the literature, let's say in the scientific realm?
I think the most recent example that is related to COVID-19. Actually, I'm using this because I'm sure a lot of people are tired of hearing COVID-related stuff. But I was helping volunteering with a nonprofit group to explore the data set called Cord-19, which was published by Allen Institute of AI and a couple of other organizations, including White House, I believe, which is a collection of thousands of scientific academic papers related to coronavirus. As you guys know, coronavirus have been around for a long time, and this year we are dealing with a different version of it. So this the analysis using NLP of this huge data set was able to like provide some valuable information to health scientists and healthcare doctors and people who are trying to understand this virus in a very short amount of time. There has been like a little challenge on Kaggle, and a lot of people contributed, and some research labs also did a lot of work on it, trying to make sense of this huge amount of data in a short amount of time so that we can produce some very effective results in terms of if a doctor has a question based on the literature trying to understand it, that doctor doesn't have to go and dig in the literature and find the paper. So he or she can just ask the question to these tools. There are a few around already. The question that it has about the virus, and then get a citation for an article that discusses that specific question or provides some sort of an answer to that question. This is just one simple example, but NLP's use cases in healthcare and education has been in a lot of the fields, finance, and any field that you can actually think of, honestly. But I think more prominent ones were in healthcare and education, that is in a way not take the place of the expert opinion, but helping them to get what they want in a very short amount of time effectively. So this was just one example, but yeah.
So does that mean that a healthcare scientist doesn't actually have to read 2,000 articles on the bioarchive before they can get the answer to something? They can just pose a question to a machine learning algorithm or a deep learning algorithm, and that's been trained on the bioarchive or the medical archive.
Yeah, I don't think I wouldn't want to simplify it that much, but at least it can get a preliminary answer or a related answer to the question, and then go and look at the paper or whatever research has been done and is available, that he or she wouldn't be able to get a hands on that quickly. So it's not necessarily, oh, ask everything to the tool and it's going to give you the answers, so you don't have to write or read or do any research. That's not the aim of the people who are trying to develop these tools. It's just a way of helping scientists and experts to reach the solution or the answer way quickly than they could have been in the past.
So is it basically like analogy of the machine is finding the right 10 papers that someone should read before being able to understand what it is that they're asking?
You mean the model should be reading?
Right.
The model should ideally be reading everything that exists on that topic to be able to produce a candidate for an answer. So it's not only 10 or 20, but everything that is out there, so that it can actually have a better understanding of what is out there and what it should return as a reply or as a response to the query.
Right. So the return of the model is basically allowing the scientist to read the output of the model so that they can get a better understanding of their question. So instead of the scientist having to read everything that the model has been trained on, they only have to read the results from the model.
I think we can say that at least it will narrow down the place that they should be looking at. And this is just one tool that was designed in a question answer format. But there are other tools that help with these large corpuses of data, textual data or voice data now, because it's the next very popular thing. But another example is social media analysis. I'm sure some of you have heard about, like, how sentiment analysis is being used to understand customer satisfaction or get the pulse of the society about what they are saying on Twitter. So these are some of the very common ways of using NLP nowadays.
Great. So Stephannie, how would you use your deep learning algorithms to try and build something that's similar to what Fatma would do in the natural language processing area?
So I'm thinking about that this weekend I went to a mall, and I was really surprised that, like, for counting people, of how many people are inside the mall, and to guarantee that, like, we are not like more, and like the mall is not more than 50% occupied. I think that's the limit that they put here in Colombia. They put a deep learning algorithm that detects people. So for me, it was really funny because they were using like a model that's trained for, like, like getting your, like your sentiment analysis from your face. But I think they decide, but they were counting with that. So I found it really funny because like you will enter one store and they will be like a bounding box around you, and that will say happy or sad. And I was like, why are they doing that? And we were debating a little bit with Edgar, and then we found out, like, oh, maybe it is cheaper, they can just get a model that does that thing, and they can use it as well to just count people. That's the thing that they wanted to do. And they will not have to, like retrain anything, or they can just deploy that into production, and that will be it. So I found that really funny, entering the stores, and you will see, like, oh, you're like, oh, you're sad, oh, you're like really you're smiling a lot. And I was like, should I smile? Yeah, I was like, oh my god, they're watching me. But basically I found that that was a really nice, like, feature they added. Also, other thing that I've seen also in the malls here, I don't know if in the US they're also doing that, but they will grab your, like, your plate from the car. So that you will be able to find your car in the parking lot if you don't remember where you put it. Yeah, so like the newest malls here have that option. I found that also funny for people that are like really like they forget things. So I don't know where I put my car, so they have a little machine you can go, and they will put, oh, here it is, your car. um yeah, I found that that's useful. Other things I've seen that I found really, like, funny are, there's some models that are able to put fake color into, like, scale gray images. So basically those models just paint as they want. They try to be consistent, we are not going to paint a tree, like, of, I don't know, blue or violet. So yeah, I've seen a lot of that, those applications. And also something that's like right now they're like hitting hard is all the generation images. So I don't know if you have played with that application that will change your gender, that has it was really funny. Like, I am a really, like, ugly man. Like, I don't know why, but I find it funny that, like, the data they trained that model, all the girls had makeup on. So if you put a man's face, they will look gorgeous because they will have all the accessories, they will have makeup on. But if you put like a girl's photo and transform it to a man, then you will be a really ugly man. You will be like, yeah, I don't know. I found that funny. Like, I test a lot with some images of my dad and also of Edgar, and it was really funny because Edgar is so pretty. He's like, he was with full makeup on. He will have like earrings and all that stuff. But I am an ugly man, thanks to that app. So yeah, I think we don't know, like, how like there's a lot of things that we use all the time that are using those, like, deep learning models, and we're not aware. But I guess that as I've worked on that, I know which type of problems, like, Facebook use or Google or Instagram. So I think that's funny, like, to know that people are like, oh my god, this is magic. But yeah, like, they just train a model with a lot of images to, like, develop that stuff. So yeah.
That's actually interesting because your example about the mall falls right along the lines of having a model that's been trained and you're nudging it to do something different. So the model in the mall was to try and detect emotional sentiment of a person's facial expression, but they were using it to count people, which is really interesting. I find that fascinating. And also your discussion about having very pretty males with a model, that's really interesting because that sounds like the model was completely biased. And what I mean by biased is that they were taking females with only makeup and accessories, and that caused some issues when you were trying to, I guess, switch the genders in the image. So that leads to a really good question. How do you guys handle bias in these types of models?
Well, it's hard. Before working more closely in data science, I was on the other side of the picture. In a way, like I used to, focus more on the models and how to create an algorithm, or like how to reproduce an algorithm, if possible at all. And using like a cleaned, a very tidy data set. I didn't have to clean the data. I didn't have to collect the data. I didn't even know in and outs of like, what are the things that goes into that data, in addition to bias, unconscious bias, stereotypes, the sample population, and all that stuff. So I guess because this is a huge problem right now for anyone who's more or less involved in data science or AI applications, as a practitioner or a researcher, that there are some tools that I think Microsoft is one of the their research lab is one of the ones that work a lot in this space, trying to produce some tools so that you can actually measure the bias of your model. And the bias of your model basically will be informed by the specific data that you have used. So there are some efforts to at least identify and reveal the bias that your model might have, or your data basically might have. But it's not perfect, and it's a problematic issue, because however big your data is, it's still a sample of a population, and you can only do so much, but it doesn't mean that you should not try. You should always be, as a data scientist or anyone who's practicing in this field, needs to be very actively conscious about what goes into the data and how they're cleaning it. What are they trying to include? What are they choosing to include or exclude in their data? Because that results in such like unpredicted consequences that you can't even imagine most of the time. I guess there are some good practices, but it's not enough yet.
So, Stephanie, I know you said that it costs a lot to be able to build these image analysis models, and you can only nudge it in a direction. So, if you have a lot of bias in the data that you've trained, can you nudge a deep learning image analysis into doing, let's say, with the changing of genders? Can you fix it with nudging the learning, so that the male faces no longer have makeup and accessories?
I think that will be really hard, because like like once I got that all the males were really like pretty women in that app, I was thinking that probably they got all their data from, like social media and things. And we women are like, we don't like to, like, like have photos on the internet where we look ugly. So so basically, I think it's really difficult to fix that, because we will need a lot of images with people that are like, with women that are not that, like, like fancy dressed for the photo. So yeah, I think it's hard, because like data is biased in, like, the data biased the model. So basically, when I was working on research, I saw that in a lot of papers, even the like clean data sets that people use for research have a lot of bias. So, for example, for detection, there's this data set that's called COCO, and that data set has a huge bias towards like humans, because they have a lot of samples of how humans, like, how we look, but of the other categories they don't have as much photos as those ones. So the model will be confused sometimes, and then you will get like, I don't know, like maybe it's a chair, but the model will say it's a human, because it has seen a lot of humans more than shares. So yeah, it is. I think it is hard because like basically the whole thing is about how your data is. So yeah.
You will probably need like the same amount, if not more, amount of data which has more diversity in it to kind of make the model unlearn or like change its opinion about what a given image is. Yeah.
There's working clients, unfortunately. But hey, oh my God, this was such a good chat. Everybody did such a great job. Thank you all for joining us today.
Thank you, everyone.
And yeah, if anybody has any feedback, find us on the chats and stuff like that. And Andy, thank you so much. I hope we can have you doing this again.
Thanks, I appreciate it.
You did a great job, y'all. Thank you, Fatma, and thank you, Stephanie. It was a lovely workshop, and I hope everybody has the best day.
Thank you, everyone.
Thank you, everyone.